So now let's talk about the derivatives of sine and cosine. Now I'm giving you these two results, and I'll prove for sine. I'll just started it here. I'll do the proof that the derivative of sine x is equal to cosine of x. And the other one that you need to know is the derivative of cosine x equals the negative of sine x. Don't get these two turned around. So here's the basic idea behind the proof. So the derivative of sine x is equal to the limit as delta x goes to 0 of sine x plus delta x minus sine x over delta x. This is just the limit definition that we've come to love and adore so much. Now, all I'm going to do is a couple of simple trig identities here. Sine of x plus delta x is actually equal to this piece right here. It's sine x cosine delta x plus cosine x sine of delta x. So this is this trig identity. So all I did is I used a trig identity. I haven't really changed anything yet. I simply used the identity. So now all I'm going to do is change the order a little bit. I'm going to take this and move this over here, right in between there. So now I'll have the limit as delta x goes to 0 of sine of x cosine delta x minus sine of x plus cosine of x sine of delta x all over delta x. So now I'm going to break these up into two different limits. I'm going to break it right there. So this is going to be, I better come down here, I'm going to run out of room. This is going to be the limit as delta x goes to 0 of, when I break this up, I'm going to factor out, I better do it in two steps so you don't get confused with what I just did. So sine of x cosine of delta x minus sine of x over delta x plus the limit as delta x goes to 0 of cosine of x sine of delta x over delta x. So I have these two different pieces here. So now here I'm going to factor out the sine of x. So I'm going to have the limit as delta x goes to 0 of sine of x times the quantity cosine delta x minus 1 over delta x plus, now this limit over here is in reference to delta x, so cosine x is like a constant. So this would be cosine of x times the limit as delta x goes to 0 of sine of delta x. And then I'm done. Because, oops, I skipped my delta x. I jumped up, small typo here. I need my delta x. There. Now I'm going to claim that I'm actually done. And the reason being is that this goes to 0. So 0 times sine of x is just 0. This is one of the special limits. This goes to 1. So all I'm left with is simply 0 plus cosine of x times 1, which is really simply cosine of x, which is what I said it was. So the derivative of sine of x is in fact cosine of x. Now the proof for showing that the derivative of cosine of x is negative sine of x is very similar to this. It's the exact same idea.